Alright, today we're talking about linear equations. And to start with, we're going to deal with slope. Slope is a ratio comparing the rates of change for y and x. And there's a few different ways to represent slope. It can be the change in y over the change in x. We often call it the rise over the run when we're describing it, because the y value controls the up and down, the rise, and the x value controls the left and right, the run. And then this is the formula for finding the slope of a line if you have 2 points on the line. So right down here on example 1, it says determine the slope of the line. We're going to do it a couple of different ways. We're going to do it using this formula first. Notice there are 2 points that have been given to us on this line. So I'm just going to grab the coordinates from those points first. So this point is at the point 0, 1, 2, 3. That point is at the coordinates 0, 3. And this point right here is at the coordinates 1, 2, 1, 2, 3, 4, 5, 6, 2, 6. So if we have 2 points on the line, we can plug the numbers from those points into this formula and find the slope of that line. Now every ordered pair, the first number is x, second number is y. First number is x, second number is y. Then the 1s and 2s are just distinguishing between the two. Because we got 2 different x's here, you can't represent the same variable use the same variable to represent 2 different numbers. So we'll call one of them x sub 1 and x sub 2. And then whichever one you decide is going to be x1, we're going to call this y1. Whichever one is x2 should have the y2 with it. So the 1s are from the same point and the 2s are from the same point. And then we're just going to substitute it into the formula. So I want y2, which is 6, minus y1, which is 3, and then x2, which is 2, minus x1, which is 0. So I've got all these numbers substituted into the formula. Then I just do the arithmetic. So in the numerator, we got 6 minus 3 is 3. In the denominator, 2 minus 0 is 2. And then if you can do your division, you divide or reduce the fraction. But in this particular case, this is already reduced, and that is the slope of that line. That is the rise over the run. Now, if they just gave you the 2 points on the line, that's the way we would typically go about finding the slope. However, when they give you a graph, there's a quicker, easier way. We can just basically count the rise and run from one point to another. So if I want to travel from this point to this point, I would go up 1, 2, 3, and I would go over 1, 2. So I had a rise of 3 and a run of 2. And I would just count it, 3 and 2, and I would know the slope was 3 over 2, rise over run. All right, now that we've talked about slope, we're going to be dealing with linear equations, and we're going to be dealing with them in 3 different forms. The first is called point-slope form, and this is the form that you would use if you were giving a point and a slope. It's y minus y1 equals m times x minus x1, and m represents the slope. And the x1 and the y1 come from the point that you know that is on the line. X and y will just stay x and y, like in a linear equation. You have an x and a y. So those will just stay as variables. In slope-intercept form is y equals mx plus b. And this has m, again, as the slope, just like it was here. And b is the y-intercept. Well, on a y-intercept, the x value is always 0. And then the y value is what we're really talking about there. Whatever the y value is at that y-intercept, that's what's going to be right here for b. And then standard form is ax plus by equals c. And when you set it up in standard form, we always want a to be positive, and we always want a to be, and then we always want a, b, and c to be whole numbers. All right, so let's take the different information they're going to give us and write some equations. So in example 2, it says write the equation of a line in the given forms. So we want to write the line with the slope of 3 through the point 2, 1 in point slope form. So remember, point slope form is this right here. Remember that m is the slope, and this tells us that the slope is 3. So I'm going to put 3 in place of m. And then the point that they give us, this is the x1, y1. So I'm going to plug those in. So y1 is 1. So I'm putting a 1 in here. and x1 is 2. So there's our equation in point-slope form. All we did was take the numbers from the point and the slope, plug them in. Alright, then we want the equation of a line with a slope of 3 through the point 21 in slope-intercept form. Notice the exact same information, but now we want it in slope-intercept form. So if I was doing this process, I would again start here. I would plug in the point and the slope. And then once I have point-slope form, then we just got to do a little bit of algebra work to get this into slope-intercept form. The first thing we need to do, we don't want any parentheses. Remember, slope-intercept form is y equals mx plus b. That's what we want this equation to look like. Y equals mx plus b. So the first thing I need to do is distribute. We don't have any parentheses in slope-intercept form. So we're doing 3 times x and 3 times negative 2. The next step, in slope-intercept form, y is all by itself on the left side of the equation. So I want it to be all by itself here. I got to get rid of that 1. Since it is being subtracted, I will do the opposite, and I will add 1. If you add 1 on one side, you need to add 1 to the other side, and I make sure to add it here where it's a like term. So negative 6 plus 1 is a negative 5. And there's our slope-intercept form, y equals mx plus b. And then the last thing we want to do with that same information, we want it in standard form. And the closest to standard form is slope-intercept form. So if I was given this problem, I would again start up here, start with point-slope form, I would work it down into slope-intercept form, and we would go from there. Standard form is ax plus by equals c. So I'm going to take this equation, I'm going to try to get it in this format. Notice that the y is on the left side of the equation, and that's where we want it. Notice that the constant is on the right side of the equation, which is where we want it. The only thing that's in the wrong place is x. Right now, x is on the right side of the equation. We want x to be on the left side of the equation. So I'm going to move it. Since it's a positive 3x, I'm going to subtract 3x to get rid of it. 3x minus 3x is 0. It's gone. So the only thing left over here now is negative 5. Now if I subtract 3x on this side, I got to do it on this side as well. And remember that these are not like terms. X and y are 2 different variables, so I'm not really subtracting with them. And I could write y minus 3x, but I really want it in this form. So I want the x to come first and then the y. So I've got a negative 3x and a positive y. So negative 3x plus y equals negative 5. And then once you have it in this order, when we're in standard form, we want to make sure that a, b, and c are all whole numbers. They are all whole numbers, so that's good. The other thing is we always want a to be positive. So if the a is negative, then I'm basically going to take everything on both sides of the equation, everything, and I'm going to multiply it by a negative 1, because that'll just change the signs. It's just changing the signs on everything in this equation. So negative 1 times a negative 3x is a positive 3x. Negative 1 times y is negative y. And a negative 1 times a negative 5 is a positive 5. And there is our equation in standard form, ax plus by equals c. Alright, so we just did all those equations. Well, it's actually the same equation in 3 different forms. These are all the same equation in point-slope form, slope-intercept form, and standard form. And we did those when we were given the slope and a point. We're going to do the same basic process, but this time we're given slightly different information. We're going to write the equation in the different forms when given 2 points that it goes through. Well, if I want to set up an equation in point-slope form, I need a point and I need a slope. Well, right now I have 2 points, so I have a point taken care of, but I don't have the slope yet. But remember, we can find the slope when we're given 2 points. Remember our slope formula, y2 minus y1 over x2 minus x1. We can take these numbers from the 2 points, substitute them in. So remember, this is x1, y1, x2, y2. We're substituting these numbers in. So y2 is 2, y1 is 4, x2 is negative 1, and x1 is 0. So I got everything substituted in. 2 minus 4 is a negative 2. Negative 1 minus 0 is still negative 1. And then we can do our division. a negative 2 divided by a negative 1. A negative divided by negative is positive, and 2 divided by 1 is 2. So we just found out the slope is 2. So now, pretty much exactly like what we did on the last problem, we now have the slope, and we can use either one of these points to set it up in point-slope form. So y1 was 4. We just found out the slope is 2. And x1 was 0. So there's our equation in point-slope form if I use this point. Now, we can set up the same equation still in point-slope form, but it might look a little different if we use this point. Let's say I use this point. Then the y1 would be 2. Slope didn't change, it's still 2. And the x1 would be a negative 1. Now we're subtracting a negative 1. When you subtract a negative, we actually add. So either one of these would be acceptable answers. Both of those are the same equation in point-slope form. But because we used a different point, it looks a little different. All right, now let's take that equation. We want to get it in slope-intercept form. We want it to be in this format. Y equals mx plus b. Now I could use either one of those because, again, they're both correct. So let me start with the first one, and I'll just show you that they come out the same. Okay, so I'm just going to do a little bit of algebra work to get it to look like this. I start with distributing. 2 times x is 2x, and 2 times 0 is 0. Now I can write plus or minus 0 out here, but that's really not going to do me any good. So I'm just going to leave it like that. And then I want to get y by itself, so I got to get rid of this 4. Since it's being subtracted, I'll add it. If I do it on one side, I got to do it on the other side. And remember, these are not like terms. We have 2 x's. We're not adding 4 more x's, so I'm not going to say 6. This is something separate. So I had 2 x's, and then I'm adding 4, and there's slope-intercept form. Y equals mx plus b. Now let's say I'd use the other equation. As long as I'm doing everything correctly, they should come out exactly the same. So same 2 steps. We're going to distribute first. So we got 2 times x and 2 times 1. And then again, I want y by itself, so I got to get rid of this number. Since it's being subtracted, I'll add it. Again, make sure you're adding it to the like term. And 2 plus 2 is 4. Notice we got the exact same thing. That's because they were the same equation, they just looked a little bit different. And for the last step, I want to get the same equation in standard form. And remember, standard form is ax plus by equals c. So the only thing that's on the wrong side of the equation when it's in slope-intercept form, when I'm trying to go to standard form, is the x. The x needs to be on the left side of the equation. Right now it's on the right side of the equation. So I'm going to subtract 2x. 2 minus 2 is 0, right? So the only thing left on this side now is 4. If I subtract it from one side, I'm subtracting it from the other side. So I got a negative 2x, and that was a positive y. And then remember, once you have it in this order, we're checking 2 things. We want to make sure a, b, and c are all whole numbers. And we also want a to be positive. So if a is negative, I am going to multiply everything by a negative 1 and just change all the signs. So that will become a positive 2x. That will become a negative y. And that will become a negative 4. And there's your equation in standard form. ax plus by equals c. All right, same basic thing here. Again, we want to write the equation of the line in the given forms. So we're going to try to write the same equation in slope-intercept form, point-slope form, and standard form. But the information we're given is a little different. This time we're given a graph. Okay, well, for slope-intercept form, remember, all you need is the slope and the y-intercept. Well, because we have a graph, we can actually see what the y-intercept is. This is the x-axis. This is the y-axis, and you should see this graph intersecting the y-axis at this point right here where the y value is 3. So I know b is going to be 3. The only thing I really need to do now is I need to know what the slope is so I can plug it right in here. I already know the y-intercept is 3. And this is the same line we found slope on earlier. So if you remember what we already did earlier, we can actually just count rise over run. Up 1, 2, 3, over 1, 2. Rise over run. And so there's the equation of that line in slope-intercept form. I got the slope, I got the y-intercept, there's the equation. Okay, for point-slope form, you need a point and you need a slope. So again, we already found the slope up 3 over 2, and we have a couple of different points we could choose from. So remember slope-intercept form, point-slope form, y minus y1 equals m times x minus x1. So let's just say we're using this point. Remember the coordinates of this point are 0, 3. So this would be your x1, y1. And I'm going to plug those in. So y1 is 3. And the slope we found earlier was 3 over 2. And then x1 is 0. So there's your equation in point-slope form if I use this point. Now there's more than one point there, so again, you could set it up differently if you want. You could use this point, 2, 6, and you could use those as your x1, y1 if you want. So it would look a little different, but it's the same equation. Y minus y1, which is 6. Slope still 3 over 2. In this case, x1 would be 2. So our equation would look like this. So either one of these equations would be acceptable. It's the same thing, just looks a little different because we used a different point. All right, and then standard form. Standard form, you're usually not going to get that straight from the graph. So you would either need to start in point-slope form or slope-intercept form, and then do a little algebra to get it into standard form. Again, slope-intercept form is the closest one to standard form. So I'm going to start with that since we already have it. Remember, standard form is ax plus by equals c. That's what we want it to look like. So the one thing that we need to move from one side to the other is the x. You have a positive 3 over 2x, so I'm going to subtract 3 over 2x. And so on the left side of the equation, I now have negative 3 over 2x. I have a positive y. On this side of the equation, I got rid of that, because when I subtract, I get 0. So the only thing left on this side is 3. So that's where I'm at now. So I got it in that order, ax plus by equals c. But remember, once we get in that order, we need to make sure we have all whole numbers. And this time we do not. So far we have. If you do not have whole numbers, if you got fractions, then what we need to do is multiply by the least common denominator. In this case, since there's only one fraction, I can just multiply by the denominator of this fraction. So if I multiply everything by 2, that will make sure I have whole numbers. Now this is also a negative. I could make this 2 steps. I could multiply by 2 to get rid of the fraction, come back, multiply by negative 1 to get rid of the negative. But I can do all of this in one step if I just multiply everything by a negative 2. That'll take care of both things at one time. So when I do that, negative 2 times a negative 3 over 2x, a negative times negative is positive, and we should get a positive 3x. Negative 2 times y is a negative 2y. And negative 2 times 3 is a negative 6. And there's our ax plus by equals c. So our standard form is 3x minus 2y equals negative 6. And the last thing we want to do in the notes today is make sure that you know how to graph a line. Now, the equation they've given us is in standard form. This is not the best form to graph it from. So you either want to have it in point-slope form or slope-intercept form to graph it. If they give you point-slope form, no need to change it. You can graph just like it is. However, most of the time we want it in slope-intercept form to graph it. So I'm going to change this into slope-intercept form. I want it to look like this, y equals mx plus b. And then I'll be able to graph it. So first thing I need to do, that x needs to move to the other side. So I have a positive 3x. So to get rid of it, I subtract 3x. 3x minus 3x is 0. It's gone. The only thing left is negative 4y on this side. If I do it on one side, I got to do it on the other side. Remember that these are not like terms. Now I could write 20 minus 3x. However, I really want it in this order. I want the x to come first. So I'm going to put negative 3x plus 20. So I moved the x. Now I still need the y to be by itself. Right now y is being multiplied by negative 4. So I'm going to divide by negative 4. Negative 4 divided by negative 4 is 1. So I get 1y, just y. Now if I do it on one side, I have to do it on the other side. And I need to make sure everything is getting divided by negative 4. So right here, negative 3x divided by negative 4. Negative divided by negative is positive. However, 4 does not go into 3. And it doesn't reduce, so it stays as 3 over 4. So I got 3 over 4x. And then 20 divided by negative 4 is a negative 5. So now I have it in slope-intercept form. Y equals mx plus b. And remember, when you're in slope-intercept form, that m is the slope and the b is the y-intercept. So what we do is we use the y-intercept to plot a point. The y-intercept's at negative 5. So I come down here, 1, 2, 3, 4, 5. There's where y is negative 5 on the y-axis. That's our y-intercept. And then we can use the slope to find more points. Remember, slope is rise over run. So from that point I've already plotted, if I go up 3 over 4, I should be at a new point on the same line. So from that point I'm going to go up 3, 1, 2, 3, over 4, 1, 2, 3, 4. There's another point on the line. And I can keep doing that. 1, 2, 3, 1, 2, 3, 4. And I can even work backwards if I want. Instead of going up and right, I can go down and left. And it'll go in the same line because a negative divided by negative would still be positive. So if I go negative in both directions, it still gives me that same positive slope. And then you just connect your dots, draw your line, and there is the graph of that line.